Hi, welcome to the final exam review, examples part C, our final part. We are going to again do it in two videos, the A questions followed by the B questions. So let's get right into it and start with 1A. If rectangle ABCD is similar to rectangle FGHJ, find the value of X. So I see the word similar, which means I want to make sure that I'm going to create a SPA table. Okay, so I'm going to start with SP, let's not put those quite so close together or I won't be able to fit anything in my SPA table. SPA. And then I need to pick one of my figures to be always in the numerator and my other figure always to be in the denominator. What do I know two of? I have a side length of 10, but I don't know the other side, so I don't have two sides. I do have two areas, so I'm going to put those under area. My up arrow 64, my down arrow 49. Okay, 64 divided by 49, does that simplify? Nope, it stays 64 over 49. Okay, that's the ratio of my areas, which I know is squared. So I need to unsquare them to figure out what my scale factor was, or the ratio of my sides. The square root of 64 is 8, and the square root of 49 is 7. So I know my scale factor, or my ratio of sides, is 8 to 7. The ratio of my parts, or the ratio of my perimeters, is also 8 to 7. These two are the same. Okay, I didn't add the V because I knew this is being rectangles. They don't have volumes, right? It needs to be a prism to be volume. So I only had to work with my SPA table, not my SPAV table. Okay, all right, so if I am trying to find a side, I can either use S for side, or I can say the side is a part of the rectangle. Either one, because they're both 8 to 7. 8 to 7 is going to equal my up arrow 10, my down arrow X. And this just needs to be cross multiplied. 8 times X and 7 times 10. So 8 times X is 8X. And 7 times 10 is 70. Divide both sides by 8. And I'm going to get 70 divided by 8 is 8.75. So my value for X, the side length, the length of this rectangle, is 8.75. My units here are meters. All right, let's look at 2A. The diameter of a sphere is 56 meters. Find the surface area to the nearest tenth. Okay, so for this one, I'm going to be looking for surface area of a sphere, which means I'm going to go grab my formula chart, which I've already downloaded and have open. And I want the area of a sphere, the surface area. So surface area of a sphere is 4 pi r squared. 4 pi r squared. S equals 4 pi r squared. So my surface area equals 4 pi times my radius squared. Now they gave me the diameter as 56. So if my diameter equals 56, then my radius is half of that, 28. My exact answer is 4 times 28 squared, 3,136 pi, but it does tell me to round to the nearest tenth, so they're probably wanting the approximate answer, times pi is 9,852.0. If it says to the tenth, that's just one place. So this is my answer, and my surface area is going to be meters squared. There's 2A. Let's look at 3A. Find the lateral area of the regular pyramid. So lateral area of a regular pyramid, my lateral equals 1/2 capital P L. My lateral area, my lateral area equals 1/2 capital P L. The base here, if it's a regular pyramid, that means I have a regular shape as my base, which means all the sides have the same length and the same angle. So it must be a square. Where my perimeter is going to be 12 plus 12 plus 12 plus 12, or 12 times 4. My area would be 12 times 12, which is 144. Although I don't need the area for this one. My lateral area is 1/2 P times the slant height, which they've given me, my L, is 20. So the lateral area is 1/2 times my perimeter, 48, times my slant height, 20. 480 units squared. For my regular pyramid. Let's look at 4A. Find the volume of the composite figure. So I'm going to need to find the volume of first the cone and then the cylinder, or vice versa. It doesn't matter which order, but I'm going to need the volume of the cone, and I'm going to add to that the volume of the cylinder. Okay, volume of a cone, 1/3 pi r squared h. 1/3 pi r squared h. 1/3 pi r squared h. Plus the volume of a cylinder. The volume of my cylinder is pi r squared h. Pi r squared h. All right, so for my cone, 1/3 pi, the radius of the cone is 7 feet squared. The height of the cone is also 7 feet. Plus pi r squared. The radius of the cylinder is 7 feet, but the height of the cylinder is only 6 feet. Okay, so for the first one, I'm going to have 1/3 times 7 squared times 7, which gives me a decimal. I'm going to go ahead and turn this into a fraction so I can have an exact answer. 343 over 3 pi. Plus the volume of my cylinder, 7 squared times 6, which gives me 294 pi. So I have 343 pi plus 294 pi. So 343 divided by 3 plus 294 as a fraction gives me 1,225 thirds pies. But let's see what that is as a decimal, because it'll make more sense as a decimal. So times pi is 1,282.817, and these are feet, and it's volume, so cubic feet. Okay, let's look at 5A. The volume of a cone is 64 cubic inches, and the height is 4 feet. What is the diameter? Okay, so if I think about a cone, okay, the volume of the cone, let's go see, volume of a cone, we actually just did that, right? Volume of a cone is right here, 1/3 pi r squared h, so I don't have to go look that up. The volume is 64, so I'm going to replace the v with 64, equals 1/3 pi r, I don't know the radius, squared h. The height, it tells me the height is 4. Okay, so the first thing I'm going to do is I'm going to get rid of that fraction by multiplying by its reciprocal. So I'm going to get rid of the 1/3 by multiplying by 3. 64 times 3 is 192. So I'm going to have 192 equals pi r squared, and then I still have that 4. Okay, so now I'm going to divide by that 4. Divide by 4. $192 divided by 4 is 48. 48 equals, that got rid of the 4, so I still have pi r squared. To get rid of the pi, I'm going to do the same thing. I'm going to divide it out. Now, when I do that, I'm going to get a decimal. So I'm going to hold on to just 48 over pi. So I'm going to write that down. I'm going to come over here so I have a little bit more room. And I'm going to say 48 over pi equals r squared. But I don't want r squared. I want to know what the radius is. So if I square root that, because the unsquaring is square rooting, my radius is the square root of 48 over pi. So let's see. The square root of 48 divided by pi. Notice the whole thing is underneath that square root bar. So it is going to square root that whole thing. When I hit enter, I get that my radius is 3.909 if I round. But it's not asking me for the radius. It's asking me for the diameter. So I know my radius is 3.909. My diameter is going to be twice that, right? My diameter, I'm going to take this answer and say multiply that answer by 2, and I'm going to get 7.818 when I round correctly. 7.818 for my diameter, and my units are, let's go ahead and make sure these are both the same units. Let's call them both inches. Otherwise, it's going to really change our answer. Inches, regular, right? Because diameter is a regular length. Okay. All right, let's look at 6a. Find the volume of the pyramid. So let's go look at our volume formula to find the volume of a pyramid. Okay, so my volume formula, when I come over here for a pyramid, is 1/3 the area of the base times the height. So my volume equals 1/3 base times height. So what is the shape of my base? The shape of my base is a right triangle. This is my base, which means I don't need to know the capital P because it's not part of my formula. I'd need to use the Pythagorean Theorem if I wanted to find it, though. I do believe it's 10. I really just need the area of the base, which for a triangle is 1/2 its base times its height. And remember, the base and the height have to come together at a 90-degree angle. So the base and the height are the 6 and the 8. 1/2 of 6 times 8. The area of the base is 24. So volume equals 1/3 of 24 times the height. And we're lucky they gave us the height is 12. Sometimes they give you the slant height and then you have to figure out what the height is, but they gave me it. So my volume equals 1/3 times 24 times 12, which is 96, and it's units. And since we're volume, it's cubed. There is 6a. Let's look at 7a. The lateral area of a cube is 576 square inches. Find the volume of a cube. Okay, so this is an interesting one because they didn't tell me anything with the lateral area, and then they want me to get to the volume. So I need to think about lateral area of a cube. A cube is a prism where all the sides are the same, right? So my lateral area is the perimeter times the height. So the lateral area, let me change colors. The lateral area is the perimeter of the base times the height. Now, if I'm looking at a cube, the base is a square. And I don't know how big the sides are, but I do know that they're all the same, right? This is x and this is x. And then if it's a cube, the height of that is also x, okay? The perimeter of this base would be 4x, right? Because it would be x plus x plus x plus x because it's a square, because it comes from a cube. the area of the base would be x times x, or x squared. The lateral area is 576. My perimeter is 4x. The height of my cube is x. So this is really 576 equals 4x squared. 576 equals 4x squared. I'm going to move over here just a little bit. Okay, so if I have 576 equals 4x squared, and I want to figure out what x is, I need to know what the side lengths are so that I can find the volume. Okay, all right, so I'm going to divide both sides by 4. 576 divided by 4 is 144. Ooh, I like that. 144 equals x squared. Then to unsquare it, we square root it. So we can see why I like that I got 144, because the square root of 144 is 12. So I know my side lengths on my figure are all 12, which means I know my perimeter now is 4 times 12. I know the area of the base is 12 times 12. Now, once I know this, okay? So now I can find the volume. My volume of a prism, which is what a cube is the area of the base times the height. The area of the base times the height. So my volume, the area of the base, since we know that x is 12, 12 times 12, the area of my base is 144. The height of my cube, since x is 12, the height is 12. So my volume is 144 times 12. My volume is 1,728 cubic inches. So again, first we had to figure out what is our side lengths on our cubes. Then we could use that to find the volume of the cube. Okay? 8. Sam rolled a die 5 times. Each time it came up even. What is the theoretical probability it will come up even again if he rolls it one more time? The nice thing about rolling a die is that every time you roll it, your probability doesn't change because nothing changes on the die. Okay? So what that means is if I'm trying to find the probability of rolling an even number the first time I roll, or the 10th time I roll, or the 7th time I roll, or the 6th time I roll, it's always the same because there's always 3 even numbers on that die, 2, 4, and 6. There's always 6 total numbers on that die. So it's always going to be 1 out of 2 rolls should be an even number, which is 50%. Okay? Let's look at 9A. Brandy asked Katie to pick 2 cards out of a deck and keep them. What is the probability that Katie first picks out a 5 of hearts, and the next card she picks out will be a 5 of diamonds? So we are looking for the probability that Katie will first pull a 5 of hearts and then a 5 of diamonds, and she is keeping the cards in between. So the probability of getting a 5 of hearts. Again, if we're not familiar with decks of cards, they're in resources for us. 5 of hearts, there's 1 5 of hearts in the whole deck of 52 cards. So 1 5 of hearts out of 52 cards. Now Katie is going to hold on to that heart, that 5 of hearts. So now she wants to get a 5 of diamonds. There is 1 5 of diamonds out of the whole deck of cards. So 1 5 of diamonds out of, not 52, because she's holding 1 card already. So there's only 51 cards left in the deck. So that's going to be 1 divided by 52 times 51 is 2,652. So that is the probability that she will pull those 2 specific cards if she just picks cards at random. Not a very good probability. Look what happens when we change this into a decimal. 1 divided by 2652, it gives me scientific notation because it can't even fit it on the screen. If I hit times 100 to turn it into a decimal or into a percentage, it's less than 1%. It is 0.04%. there are very slim possibilities that she's going to pull a 5 of hearts followed by a 5 of diamonds. Okay, let's look at 10A. Find the probability that if a bird lands in a field, it will land where there is corn growing. So I'm trying to find basically what's the probability that we're going to land in this section of this whole rectangle. So the probability that we land in corn. Okay, so what I first need to do is figure out what is the area of the corn. Well, the corn is a 425 section or length times a 500 width. So the area for the corn is 425 times 500. My area, 425 times 500, oops, there we go, is a really big number, 212,500. So that's my favorable area, 212,500. Over what's the total area that bird's going to land in if it just lands randomly in the field. So that's going to be 425 plus 175 is 600. And 500 plus 100 is also 600. So we have a square field, 600 by 600. So the area of the field is 600 times 600, or 600 squared, which is 360,000 square feet. So let's reduce that probability. 212,500 divided by 360,000. Math, fraction, enter, is 85 over 144. Is the probability that bird just randomly lands in the section that has corn. As a percentage, math, decimal, enter, times 100, 59%, 59.03, really, if we wanted to round it to 2 places. I'm just going to round to 1, so I'm going to say 59%. And again, on your test for your final, it will be multiple choice. It may ask you on your practice test to round to a specific place. Okay? All right, in the next video, oh, nope, sorry. I almost forgot about 11. We're spinning a wheel. Winnie is going to spin the spinner below twice. Find each probability. Okay, so first we're trying to find the probability that we land greater than a 3, and then that we get a 4. Okay, so greater than a 3, and then 4. So which ones are greater than 3? 1, 2, 3, 4, 5. There are 5 sections greater than 3 out of 8 total sections. And then the probability that we get a 4, there's 1 4 out of 8 total sections. So that's going to be 5 times 1, 8 times 8, 5 out of 64. I don't believe that reduces. Nope. So then as a decimal, times 100, that's going to be 7.8%. Okay, then we're going to look at the probability of landing on a multiple of 3. So my multiples of 3, that would be 3, 6, and it's just those 2, right? So just 2 out of 8. And then to land on a 5, there's 1 5 on that whole board, so 1 out of 8. 2 times 1 is 2. 8 times 8 is 64. So that's going to be 2 divided by 64. Math, make it a fraction. 1 out of 32. Math, make it a decimal. Times 100. Gives me 3.1%. I'm going to just round to one place. And last but not least, what's the probability of landing on a 7 and then landing on 1? There's 1 7 on that whole board. Just the 1 7. So 1 out of 8 times, and then landing on a 1, there's 1 on the board out of 8. So that is going to be 1 times 1, 8 times 8. 164, that is not going to reduce. 1 divided by 64 times 100 is 1.6%. So not very good chance of landing on those two specific numbers. Okay. All right, if you still have any questions, then hopefully when you watch the B section of this video, it'll answer them. If not, make sure that you are asking in class when you have access to your teacher. Thank you so much for watching, and come on back to see how we can use Part A to help us with Part B. Thanks for watching.